Hello, good morning. In the previous class, we are describing the basic of torsional pendulum, is what is the working of torsional pendulum or what is the mechanism behind the torsional pendulum. In the today's class, we are continuing the topic expression for the periodic time and the modulus of rigidity. So in the previous class, we are taking the shortcut. If theta radian is the instantaneous angular displacement, then the restoring torque is given by, this is the torque is equals to minus c into theta. So this c is called torsional constant. So this c is the torsional constant of the wire. Okay, so in this expression there is a negative sign. So this negative sign shows that the torque tends to rotate the body opposite to the angular displacements. Where the direction of angular displacement we are taking the clockwise, then the restoring torque tends this body in the anti-clockwise and anti-clockwise direction. Okay, means opposite to the angular displacement. The torque is, so this torque, this is the restoring torque, is related to the angular acceleration, that is d square theta by dt square. Okay, this is the angular acceleration. If theta is the angular displacement, then angular acceleration is the d square theta by dt square. So this torque is related to the angular acceleration, that is this torque is equals to, this is also torque and this is also torque. So this torque is nothing but the I into d square theta by dt square. Means this torque is also related to the angular displacement and this torque is also related to the angular accelerations. So this is the expression for the relation between the torque and the angular acceleration d square theta by dt square, that is torque is equals to I into d square theta by dt square. This I is the, where I is the moment of inertia. This I is the moment of inertia of body. Where the body is taken, it has the metal body and about the axis of rotation. About the axis of rotation. Okay. So this I is nothing but the moment of inertia of the body about the axis of rotation. So comparing this equation, this is the first number equation and this is the second number equation. So after comparison, both have the value of restoring torque or even torque. Both have left hand side is same, that is the torque is equals to, this is torque, then left hand side is also equal. So we get, after comparing equation 1 and 2, we get I into d square theta by dt square is equals to minus c into theta. Okay, so this is the second order differential. So we write this first, d square theta by dt square, and next term we are taking plus sign, this sign, that is the plus c, and this is the multiplied term, we get divide into theta is equals to 0. Okay, d square theta plus c by I theta is equals to 0. So this is the third number equation. So this equation is nothing but the second order differential equation, that is d square theta by dt square plus, this is the constant term, this is again theta is equals to 0. So this is the differential equation of SHM, simple harmonic motion of angular frequency. Means this is the angular, theta is the here the second order differential function. So this is the differential equation of SHM of angular frequency. Okay, so this is the differential equation of SHM. Okay, angular frequency okay, and which is the angular frequency? If theta is the angular displacement, d square theta by dt square is the angular acceleration, then angular frequency of this equation, that is denoted by the letter omega square. Omega square is equals to, so this is the constant we take as the omega, and this omega square is equals to C by I. Okay, after comparing this equation with the differential equation of SHM, we get omega square is equals to C by I, and omega is equals to under root of C by I. Okay, so this is the angular frequency. Therefore, the time period of oscillation, that is denoted by the capital T, and this capital T is nothing but the, we know that time period is equals to twice pi by omega. So after putting this value, we get T is equals to twice pi divided by under root C divided by I. Okay. So if we are taking as a multiplication side, that is T is equals to twice pi under root I by C. So this is the equation for time period of oscillation of torsional pendulum. So this is nothing but the fourth number equation. Okay, and we know that the value of this C in the previous expression, that is the torsion of a cylinder, static torsion of a cylinder. So in that we are calculating the value of a C. So this value is nothing but this value of C is the pi neta r to the power 4 divided by twice L. So this value C, but C is equals to pi neta r to the power 4 divided by twice L. Okay, pi neta r to the power 4 divided by twice L. So therefore, after putting this value, we get T is equals to twice pi under root I divided by pi neta r to the power 4 divided by twice L, and after calculation this is nothing but the twice pi, this goes to numerator side, that is twice pi under root of twice I L divided by pi neta r to the power 4. So this is the time period of torsional pendulum, that is T is equals to twice pi under root of twice I L pi neta r to the power 4. Okay, here twice pi is the constant, I is the moment of inertia of a body, L is the length of the wire which we hang this torsional pendulum with the rigid support, pi is also constant, neta is the modulus of rigidity of the wire, and r is the radius of the wire. Okay, so from this equation we can calculate the modulus of rigidity. Okay, so we know that this P is equals to twice pi under root of twice I L divided by pi neta r to the power 4. So we want this letter eta. So that's why squaring both sides of this equation, we get T square is equals to 4 pi square into twice I L divided by pi neta r to the power 4. We get this value T square is equals to 4 pi square twice I L pi neta r to the power 4. Therefore, from this equation we take neta as the next side. Therefore, neta is equals to this pi and pi cancel. Okay. Then again, so we get 4 pi, 4 into 2, that is the 8 pi I L, and divided by t square r to the power 4. Okay. So this is the expression for modulus of rigidity by using torsional pendulum. So in your experiment record, this is the formula which we had calculated, 8 pi I L divided by t square r to the power 4. So by using this equation, we can calculate the modulus of rigidity of the wire, which we use in connection of torsional pendulum to the rigid support. Okay, so this is the modulus of rigidity of the wire. So by using the equation, we can calculate the modulus of rigidity of the wire. Okay.